So what is chi-square distribution? So a random variable q is said to follow a chi-square distribution, okay, if it can be denoted as sum of squares of n independent standard normal distribution. Okay, so for example, so what is a standard normal distribution? So this is n01. Let me do. So this is a standard normal distribution. Standard normal distribution. So this is standardized. So we know this. So I was telling you the actual definition. Let me tell you in simple terms. So we have such standardized normal distribution, which is mean centered and variance scaled. So your mean is centered to 0 and your variance, the sigma square, is scaled to 1. So you have this, and you have n such independent random variables. Okay, when you have n such independent random variables, and when you take a sum of that, and the distribution that you get out of that, those squared sum of these standard normal distributions, random variables, that distribution is called chi-square distribution. So it is written as, so the symbol is a fancy x. Let me use a different, like this, chi-square, and it is also has a degrees of freedom. I'll talk about this. I've talked about this in T distribution also. Okay, so this is the same degrees of freedom, and this is equal to summation I equal to 1 to n zi square, and this I is, so if you expand it, this will be z1 square plus z2 square plus so on till zn square. These are n independent standard normal distributions. Simple. Okay, you just square them and add them up. So we know the properties of this, and we just square them and add them up, and the distribution that you get out of this, that is called chi-square distribution. As simple as that. So what are the properties of chi-square distribution? So this is simple. Some properties. So this will always be non-negative. This will always be non-negative, right? Because this is sum of squares. So that is obvious. So sum of squares will never be negative. So this will always be non-negative. And then the distribution, when you plot the distribution, this is asymmetric. This is not like normal, which is symmetric. Generally, it's skewed towards the right. I'll show you the picture of that. Okay, that is skewed towards right, and the shape depends on, as T distribution, whenever we have degrees of freedom, the shape depends on your degrees of freedom. So as the degrees of freedom change, the shape will change. Okay, and as the degrees of freedom increases more and more, it will become more and more symmetrical, and it becomes very large. It will be very close to the normal distribution. It will become symmetric. Let me show you the distribution. I have opened it here. This is your Wikipedia. This has become very small. This is chi-square distribution, right? Okay, let me take a screenshot of this. I'll just show you. So you can see from here itself. I'll highlight this in my notes, that the distributions for different degrees of freedom, right? You have different. Okay, the K here is the degrees of freedom. Okay, so let's come back to the note. I have brought it here. I have the note is visible. Okay, so this K here, this is for degrees of freedom, and you can see that as K changes, it is becoming more and more kind of symmetrical. It is becoming, and if you can see that is skewed towards the right. That's what I wanted to show you. This is the kind of distribution. So all the distributions are not symmetric. Even T was symmetric. So I wanted to expose you to another kind of distribution. Okay.